Hello everyone, my name is Kanchan and today I am presenting my project on microprocessor based DC motor control using start and soft stop. So DC motors are widely used in industries, robotics and automation system due to their simplicity and ease of control. However, one major problem with DC motor is that when they start suddenly and a high current flow through a circuit which can damage the motor and reduce. Similarly, sudden stopping of motor can cause mechanical stress or jerks. To overcome these issues, we use the concept of soft start and soft stop. So the main objective of the project is to control the speed of DC motor using microprocessor to implement soft start to reduce initial current and to implement soft stop to avoid sudden stopping to improve efficiency and lifespan of the motor. So next we will discuss the working principle of the motor. So in this system, a microprocessor is used to control the motor. So the microprocessor generates a control signal. These signals are sent to motor driver circuits. The motor driver circuits controls the voltage applied to the DC motor. So instead of giving the full voltage instantly, the microprocessor gradually increase the voltage using delay logic or stepwise control. Similarly, during stopping, voltage is reduced gradually, not sudden. So this results in smooth acceleration and de-acceleration of the motor. So the force on the conductor is given by B cross I cross L. B is the magnetic flux density and I is the current through the conductor and L is the length. So the torque we will get is F cross R, force into the distance. Okay, and this is calculated by the Fleming left hand rule. Force can be calculated. So next is speed control concept. So the speed of DC motor depends on the back EMF and armature resistance. So this speed equation is given by N is directly proportional to V minus IA cross IR A divided by phi. So V is the supply voltage, IA is the armature current, RA is the armature resistance, and phi is the magnetic flux. When we increase voltage, a higher back EMF generate which will result in more speed. And in this experiment, the digital value from 8085 we send it to DAC and then it convert into analog voltage and then the motor speed can change. By controlling the output bit sent to the DAC, we control the motor speed precisely. So next is the block diagram. So first is microprocessor 8085 microprocessor. This is the digital control, and then we will send the 8 bit data bus to 8255. Uh, it is 8255 PPI from the input output port expander, and then this send the digital bit to digital to analog converter. And then it will generate the analog voltage which we will give to the op amplifier, and this will give the amplified voltage to the DC motor, which will give us the mechanical output. So the next is the concept of the soft start. Next, we will discuss the concept of soft start. So the soft starts means gradually increase of motor speed from zero to maximum. So why we need this? So to avoid the to avoid the sudden high current inrush that can damage the motor windings, and to prevent the mechanical shock and gear damage in loaded system. So in 8085 program, the accumulator starts as 00H and then increase by 05H of the each step. So each step is followed by the cold delay, giving motor time to respond. So in this we can see that each delay is increased by 05H step, and this will continue until the accumulator reaches its full speed, that is FFH. Here it reaches its full speed FFH. And next is a concept of the soft stop. Softer stroke. So means a softer stroke means the gradual decrease in steps. Means instead of increasing strokes, instead of sudden stroke, voltage is reducing step by steps. And in the same, the voltage is reduced by the step of 505H. Here is it is maximum at FFH and it is decreased to 00H. We if we can see this in the graph also, it is a sudden start and it will remain constant after reach its maximum value, and the sudden stops, it it is maximum and then it is decreasing gradually by the linear motion. So the next is the program logic. So first we will start the program. We will initialize the register. And initialize the register. Output goes to output 40H and set 8255 port A as output. So then the soft start will load A 00H. Then it's sent to 41H. Then add 05H that generate delay, and then it attained the full speed, that is FFH, and then then we apply the code of soft stop, which here is the maximum, and after the stop it will stop the motor will stop, and it is 00H, and then the program will end. So the main is start the program, initialize, and then soft start, then it will attain full speed, then we will apply the code of soft stop and the motor will finally stop at the end. So next is the address wise memory table. Here is the address, here is the opcode, and here are the mnemonics. So this is all that we discussed recently. So this is the memory table that we generate the delay subroutine. Delay subroutine. So how the delay work? So B and C registers each loaded with FFH means 255 counts, creating a nesting loop. Inner loop decrease C JNX 2034 runs 255 times before B is decremented once. So the total delay cycles will become 255 cross 255, that is 65,025 loops. That is noticeable time delay. So the read instructions returns control back to the main program after the complete delay completes. So this is the address wise code. So next we will discuss about the step by step working. We will, as we discussed recently, this is the phase one of the soft start. The accumulator value is starting at 00H, and then we will rise at full speed until FFH. Then it full speed holds, and then we will gradually start decreasing its speed, and start until it becomes zero, and then we add the delay at 2030 address. So this is the graph of showing the time versus speed or voltage, which will showing the soft start and soft stop graph. So this is the observation. Initially, we are giving some torque to the motor, so it will attain the full speed at this time. This will attain full speed, and then it will stops. So what are the results? So the experiment conducted successfully on the 8085 microprocessor kit. The motor starts smoothly from rest. No jerk or sudden current surge observed. Speed gradually increased from 00H to FFH during the soft start phase. Motor ran at the full speed, that is FFH, during the steady state operation. Motor gradually decreases the speed from FFH to 00H during the soft stop phase. The motor stops completely and smoothly with no mechanical vibration. Here, some limitations were also observed at the that we are giving some torque to the DC motor. or some connection issues of the inside the DC motor. So what are the advantages of the of this project? So by using this, we can increase the motor life. We will reduce the mechanical stress. We will improve the safety, and the smooth operation is conduct out. So what is the conclusion we will far discuss? So we will successfully demonstrated start and soft smooth of the DC motor using 8085. We are understanding how digital values control motor speed through digital to analog converter and op-amp. We learned the importance of gradual start transactions for motor and system protections, mastered keys 8085 instruction, and verified the speed equation, that is N is directly proportional to V minus IR into A. Through the practical observation, this experiment praised the digital microprocessor programmable and the real world motor control. Thank you for watching this video.